Let's say we have built a model of linear regression, but uh, but the root cause remains. How do we measure the relative success of the model in explaining the data compared to the just average guessing? So after that we have computed the slope and the influence of the each factor. How much model, how much is the accuracy of the model? We are concerned about this and how it is better than the average guessing. How much better? Let's say we want to compute this. How much better is my model, are my model predictions than the average guessing? So how do we calculate this? It's again a simple statistical formula, that is, we divide the errors of my let's say we divide the variance of errors using model predictions by the variance of error using average prediction, right? So residual sum square, so all the residuals we square them and we take a sum of residuals square, and the residuals when we do the average guessing. Let's say this is residuals by formed by, this is the average guessing, and we do the square. So if my residuals are this ratio between the residuals of my model's prediction divided by the residuals of the average guessing is, let's say my this is very low compared to this, so the value will be close to 0, and 1 minus 0 will, r square will be close to 1. But if my model's residuals and the residuals of the average predictions are almost equal, the ratio would be 1, 1 minus 1 would be 0, so r square would be 0. That means my model is just as good as the mean model. And if the residuals that my model is making is worse than the average mean model, so this would be greater than 1. So 1 minus, let's say, negative value which is greater than 1, let's say infinity, this would be more negative. So the r square ranges from minus infinity to 1, and this will be an open bracket. My r square ranges from minus infinity to plus 1. And r square can be interpreted as how much my model is able to explain the target variable. So combining all the independent features, how much variance is explained by features. If the variance explained by the features is close, so the r square would be 1. If not, if is as good as mean model, it would be 0, and worse, and it would be a negative value, right? Negative value less than 0. So r square, no matter the influence, feature influence, yes. So the r square has a limitation. So r square is just the ratio of RSS by TSS. If I add a feature, let's say I have built a model with 9 features. If I add another feature, which is, let's say, a noisy feature which is not having a correlation at my target variable, and it adds complete it adds no value in predicting the target. Let's say the correlation is very weak, let's say 0.001 correlation with the target variable. So if I include this feature in my model predictions, what happens is my total sum square will boot up, will spike. but in comparison this value will get up, but why my total sum square value will go up? I don't understand, because y depends upon the mean value, right? Let's say for an r square, let's say we have y print y minus y print y minus y print का square, and we compute y mean also, y mean and y minus y mean का square, y prediction, say 8 7 6 2 3 4 8 10 14 13, right? These are my predictions. So mean of y would be 8 plus 14 plus 17 plus 25 9 39, so 39 by 5 and 2 3 4 5, so it would be something around 7.40 7.8. So my mean is 7.8, so I'll subtract every value with 7.8. No, this is just the mean, right? This is 7.8, and y minus y mean ka square, so let's say 7.8 minus 8 ka square, 7.8 minus 6 का square, 7.8 minus 3 का square, 7.8 minus 8 का square, and 7.8 minus 14 का square, right? But I'm not able to visualize that why my r square is getting up, because the mean stays the same no matter the feature value. So why does my TSS goes up when I add a new feature? No, the TSS stays the same, right? So TSS stays the same because it is dependent upon the mean, but my RSS will go down, right? So even if it is a noisy feature, it will reduce my RSS because it is adding some value so that my overall RSS goes down, but my TSS remains the same, so the overall ratio will decrease. So if the ratio will decrease, 1 minus the decreased value, the RSS would increase. 1 minus decreased value will be my new r square, so the r square will always increase because my RSS decreases no matter the feature signal strength, but my TSS is not dependent upon the the feature, it is just computing the mean. So we have another formula to verify whether the added feature is adding some value or not. So we look at the adjusted r square formula, which is adjusted r square is given by 1 minus r square n minus 1 divided by n minus k minus 1, where n and k is number of observations and number of predictors. N is observations and k is number of features. So if you compare the fraction n minus 1 upon n minus k minus 1 acts as a penalty that increases as you add more variables. So this term, let's say if you neglect this term, 1 minus 1 minus r square, this is same, this is the r square formula, right? But this term n minus 1 by n minus 1 by k acts as a some adjustment that will result in, will only result if the number of features so how do we check? Let's say if we compare the two value, after adding the feature we compute the adjusted r square, and before compute the r square, and then we compare the value. So if the added feature is having some signal, the adjusted r square would stay the same or it would decrease. What happened here? Adjusted r square will increase or decrease. Yeah. So adjusted r square increases when it adds a value and decreases when it adds no value. This should happen. Okay, so this is the thing, and adjusted r square. Okay, done.